My name is Christopher Boyd, and I'm a PhD student studying electrical engineering at the University of Michigan. Today I'm going to talk with you about my research topic. And to begin, I'd like to pose a question, and that is, what do the following objects have in common? We have a smartphone, video game systems like the Wii, Xbox, and PlayStation, electronic stability control systems, which prevent your car from skidding if you need to make a sharp turn on an icy road, a Segway personal transporter, and a self-driving car. So let's take a few moments to think about what these devices have in common. Okay, so hopefully you've been able to think of a few ways in which these devices are similar. One that really sticks out to me, though, is that they all use sensors to measure motion. They're using that information to do different things, though. The smartphone, video game system, and the Segway are measuring motion as a way to control those devices, while the electronic stability control and the self-driving car are measuring motion, sending that information to a computer, which then makes a decision about how to maneuver the vehicle. But sensors are what connect all of these devices. So what is a sensor? A sensor is a device that measures or detects information about its environment. Some everyday examples of sensors include a thermometer, your hands, a camera, your eyes, a microphone, and your ears. And what connects all of these sensors together is that they convert one form of energy or information into another. So for example, the camera and the eye convert light rays into electronic signals which can be understood by a computer or your brain. Inertial sensors are a special type of sensor which are used to measure the motion of objects. And typically, we classify sensors into two categories. The first is sensors that measure straight line motion, and those are called accelerometers. And the second are sensors that measure rotation, and those are called gyroscopes. I specifically work with gyroscopes in my research. Here's an example of a gyroscope that maybe you've seen before. I actually work with gyroscopes that look very different from this, though. These devices are called MEMS gyroscopes, and MEMS stands for Micro Electromechanical Systems. One way to think about MEMS is to imagine that you have a shrink ray, and you can shrink any object you want down so small that you need a microscope to study its features. MEMS allows us to realize very tiny sensors, so small that we can place them into smartphones and other types of technology. The microstructure that I work with is a small wine glass. And what's interesting about these tiny wine glasses is that they're about the size of an apple seed. The challenge in MEMS, though, is creating a device that has very, very tiny features. So you can see in the box region a MEMS gyroscope with electrodes surrounding it. The gap between the electrodes and that shell is about 14 micrometers. And for reference, the average thickness of a human hair is about 100 micrometers. And now I'll explain how these tiny wine glasses can operate as gyroscopes. In order to do this, I'll use the example of the Foucault Pendulum, which maybe you've seen in a museum before. These pendulums can measure the rotation of the Earth. The way they work is that as they swing throughout the day, the plane that this pendulum swings in actually begins to move, and that's because the Earth is rotating underneath it, and the pendulum has so much mass that it actually wants to resist that motion. The MEMS gyroscope operates similarly to the Foucault pendulum. First, we force the gyroscope to vibrate, and then we measure the angle between some point on the outside of the gyroscope and the maximum point of deflection of the vibrating shell, called the antinode. When the gyroscope is not rotating, this vibration pattern is fixed. However, if we rotated the gyroscope, we would notice that the vibrating wave pattern actually changes. And by keeping track of these changes, we can measure how the device rotated and how fast it rotated. In this case, the vibration pattern lags the reference point of the gyroscope by 27 degrees. This depends only on the geometry of the device, and it's repeatable, so we can use it as a sensor. And finally, I'd like to leave you with the message that sensors are everywhere. And I would encourage you to look for places where MEMS inertial sensors are working behind the scenes in your life. My favorite application for this technology is actually the Segway personal transporter. The reason why I really like this device is because it combines gyroscopes and accelerometers, an embedded computer, and a motor to allow the user to balance themselves on only 2 wheels and also to drive this device by only shifting their body weight. I think that this type of technology will really change the way that we interact with machines and will also greatly help the field of robotics and self-driving cars.